cube roots. So open up your packet to page 8 to get started, or if you weren't able to print out the packet, take out a piece of graph paper to write the examples and the notes on. Be sure to number the graph paper with the page and question number in case I ask you to submit this later in the week. On page 8, question number 1 asks you to graph an exponential function. An exponential means that you will be graphing an equation with an exponent of x. So anytime you see an exponent of x, that is going to be an exponential. The first thing you need to do is to make a table of values. So type into your calculator y equals 2, use the caret button, and raise it to the x power. Now when you look at your table, your y values must consist of a few decimals and a few integer values. So for this one, the best numbers to use would be from -3 to 3. Then again, you do have to write down the decimal values as well. Once you write down your table, now you want to plot the points. It's normally easier on an exponential to start plotting the points of the integer values first, but that would be up to you. 2, 4, 1, 2, 0, 1. Now, very important with an exponential and the decimal values is that if you look at your table on your calculator, you're going to notice the y values keep getting smaller and smaller, but it is never ever going to get down to 0. The reason is an exponential is going to start to even out on the bottom, and when you draw this in, it is very important that when you extend the line on the bottom, that it never touches the x-axis or you do lose a point. Again, it will always get closer and closer to the x-axis, but it will never ever touch it. So be careful when you're drawing in your exponential. Don't forget to label it f of x equals 2 to the x power. Now this exponential is going to be increasing, or it's also referred to as a growth, since from left to right, this exponential is going upward. If you were to have an exponential in this direction, this would be a decrease or a decay. Now the next exponential that they ask you to graph has a +3 on the outside. When you type this into your calculator, y equals 2 to the x power, make sure that you arrow to the right before you do +3, otherwise the 3 is going to be connected up in the exponent. Since the 3 is not connected to the exponent, that means that this is going to have a shift going up 3. Now the same as before, you need to take and make a table of values. Your table must, for an exponential, have at least 3 decimal values and at least 3 integer values for the y's. So for this one, my x's do turn out to be -3 to 3 again. Now you can always put in more x values as well, depending on how big your graph is. But at minimum, you should have at least one calculator length. Then write in your y's. Now, when you're graphing this one then, again, 311 is not going to fit on the graph, but 27 will fit. 2, 7, 1, 5, 0, 4. And then you're going to notice you have 3.5, 3.25, 3.125. So in this case, it starts to level off around 3. So when you're graphing your exponential, make sure that on the bottom, it's going to be getting closer and closer and closer to 3, but never actually touching it. That's called an asymptote, which we'll talk about later on with exponentials. But it's very important that it never touches the number 3. Y equals, or actually, sorry, it should be f of x equals f of x equals 2 to the x power plus 3. Again, it's increasing, and that also has a growth. Now for question number 1, they're asking about the domain. The domain of the blue one and the red one are actually both going to be the same. Furthest to the left, this is going, would be negative infinity on the x-axis, and since there's arrows, furthest to the right would be infinity, which always gets parentheses, negative infinity to infinity. The range, my lowest y value, though, does differ on both of them. My lowest y value for the blue one is at 0, and the highest is going to be infinity. Now, since it never actually touches at 0, make sure that you're using a parenthesis for it. The range for the red one, it's getting closer and closer to 3, but never touching it, so it would be going from 3 to infinity. Let's go on to the next graph. Your next graph is the graph of a square root, which we've actually done before. So since this is your review, pause the video now and graph both of the square roots. So for your graph of the square root, again, first they're asking you to graph f of x equals the square root of x, which is the parent function. You make your table, and remember, to graph a square root, you look for the word error on the table, and that's how you know to start your points. So for my f of x equals the square root of x, I will be starting at 0, 0, and going towards the right. Don't forget to put an arrow and label it. For my next one, q of x is equal to the square root of x plus 5. Having the 5 on the inside is going to be a shift left 5. Again, look for the word error, you make your table, and then you plot the points. Now the domain is going to be the furthest to the left. The furthest to the left for the red one is going to be at 0, and going to the right would be infinity. Since it's a closed circle at 0, you would have a bracket around the 0, and infinity would get a parenthesis. You can also write that as x is greater than or equal to 0. My range is going to be, my lowest value is still 0. Since there's an arrow, my highest is going to be infinity, or you could write it as y is greater than or equal to 0. For my new equation when I graphed it, now furthest to the left is going to be at negative 5, and furthest to the right would be infinity. The range would stay the same, which would be from 0 to infinity. Question number 2, they're asking you to graph a cubic function, meaning that there's an exponent of 3. f of x equals x to the third power is going to be the parent function. The first thing, again, that you need to do is you need to take and make a table of values. Your table for a cubic, when you write it out, you're going to notice that you have your same y values, but they're going to be negations of each other. So for this one, I'm going to be graphing it from negative 3 to 3, and you're going to see negative 27, negative 8, negative 1, 0, 1, 8, and 27. So I have 27 and negative 27, negative 8, and positive 8. And you're going to notice, since it's a parent function, it goes through at 0, 0. For my next table, when you make it, you're looking for the same thing in your y's, where you're going to have the same numbers, but negations of each other. So for my next graph, I'm going to be going from negative 6 to 0. Fill in your table now and draw both of the graphs. Now on my first graph, y equals x to the third power. When I'm graphing this table, I made this one red. You're going to notice in the middle, when you're graphing a cubic, you will have 3 points in a row, here, here, and here, and then it'll start to go up either high or low. It is a curve, so make sure that you're not using a ruler. And again, this is the parent function. It will always be going through at 0, 0. Negative 27 and 27 do not fit in the graph, so obviously you don't have to plot those. For my blue one, I took and I made this again from -6 to 0. You're going to notice the 3 points in the middle here. That's what you're going to be looking at for the shift, is this center point. So you can tell that this shifted to the left 4. You can also see that by looking at the equation. The inside number goes left or right in the opposite direction. Also, on the graph, I just realized that I labeled mine with y equals. Make sure you're labeling it with whatever it is the question gives you. In this case, they both do say f of x. So that would be always the shape of a cubic. It looks like a squiggly S, sort of. Now, the next question, go on to page 9. On page 9, up on the top, they're asking you to graph the cube root. The equation that they're giving you for g of x is the parent function. To get that on the calculator, you're going to go to y equals first, then hit the math button. It's going to be math number 4, which is going to be the cube root symbol. You have to take and make a table for this. Now, for this one, in order to make the table, you do have to pay attention to your graph because it's going to have a lot of decimals within the table. You're obviously not going to be plotting those. So your graph is a 10 by 10. So you want to take and scroll to -10 and see if there's any integer values. And in this case, you're going to see -8, -2, and you are able to leave out all of the decimal values for this one to get enough points for you to take and have just integer values to plot. The same thing for your other graph when you make your table. Since it's a 10 by 10, take and look from -10 to 10, and you're going to see that -6 will be the first one that has an integer value that's going to fit on your graph paper. That's what you're looking for when you're making out this table. Pause your video now and graph both of these, arrows on the end, and label it. Now, once you take and plot the points for the cube root, you're going to notice that it's similar to the cubic in that it does have the squiggly shape, but it is going sideways. Make sure you have arrows on the end when you're doing this. Now, again, for the parent function, it goes through at 0, 0, and you're going to notice that there will be the 3 points in a row, just like the cubic had. When you graph the other one, this 2 on the inside is implying that it's going to be a shift to the right 2. Some people look at the graphs and they go, oh, well, didn't the blue one go below it? You're always looking at this center point of the 3. So you're going to see from my original to the new one that the entire graph shifted to the right 2. For the domain and range for both of them, they're going to be the same. The furthest to the left that they both go is -infinity, and the furthest to the right would be infinity. The same with my range. The lowest would be -infinity. The highest would be infinity, since there are arrows on the end. It does have the same domain and range as the cubic has from question number 4. Now the multiple choice on the bottom, the best way to do these is going to be to use your calculator. If it's a cubic function, a cubic again means that it's going to be an exponent of 3. If you go to your calculator and type in y equals x to the 3rd power, you're going to see a shape similar to choice D. It's not going to be the same because there's a reflection, but it would definitely be that general shape. Whereas C would be an absolute value graph, and A would be an exponential. For number 6, they're also asking for a cubic, so you would type in your calculator y equals x to the 3rd power, and again you're going to notice that it's similar to choice C. A would be the graph of a square root, B is an absolute value, and D would have to be a quadratic. Number 7, all of the choices are cubics, so in order to do number 7, type the equation into your y equals into the calculator and look at the graph or the table to match up the points, and you're going to see that it's choice D. Now for homework tonight, you're going to have a Delta Math assignment, which is not due until April 14th. I recommend getting it done early instead of waiting until the last minute. Have a wonderful Wednesday. I will talk to you soon. Bye.